Good morning, everyone. I welcome you to day 2. From where we resumed yesterday, we are going to continue from there. Hope you had a great night. I'm just wondering if there are some people who managed to do the homework such that we give them the first 5 minutes. Even if we get 1 or 2 people, we give you each 2 to 3 minutes such that you present the work that I left. You can raise your hand and then Amit will help us to give you the right to join the panelists group such that you're able to present. Amit, are you there? Good morning. Amit?
Yeah, it's okay. So can you select anyone who you want to present?
Yeah, we can get the first one, Hail, because I saw he has put his hand already, and then we can have the second one.
Okay.
Their hands are already up.
Okay. I think they can go ahead.
Okay. Haile, please share with us what you managed to do with the homework, and then we get started.
Hello, good morning.
Good morning.
This is my first class just to attend the training, so I don't take any exam at home. This is my first time, that's why just to leave the message. The first session.
Okay. Okay, fine. Okay, it's okay. Then Oluwapoli, you managed to do the homework?
Hello, Doctor. Good morning.
Yes, good morning.
Can I share my screen?
It's all right. Please go ahead.
I don't have option share screen here.
What options do you have? On your screen, don't you have a green screen which has, a green icon that shows share screen below as you check on your computer down there? Tell me the different icons you're seeing. There's what we have: a chat, Q&A, then share screen. Oh. Okay.
Hello.
Yes, we can hear you. Go ahead, please.
Can you see my screen?
Yes, we can.
Okay. I installed my package and I show all the packages. Then I set my directory. And hello, can you hear me?
Yes, we can. Please continue.
Okay. After that, I do my directory by manual, my session. Do directory and I can find the this. After that, I go to view my 2 files with weight A and weight B and set it as df1 by command df1 less than minus read CV weight A and weight B. After that, I do the structure for F1 and find it 11 rows and 5 columns. with 5 variables, and weight B with 14 rows with 3 variables. After that, do the left join, and the left join keep everything in table A, and add the other in table from table weight B, and ignore the rows 13 and 14. After that, did the right join. Keep all elements in work B, in work B, and the other write it as NA, and in inner join. Merge all common rows in A and B. This is A and this B when I find it. After that, I did full joint between two everything in the between two data set. I'll full joint, merge everything between the two tables. But I don't know, this is correct, doctor, or not? I tried.
Thank you so much, Muna, for the great work. Yes, what you
Is it right
Thanks
or
for the
not,
great work.
doctor? This is
No,
first
it is
time
right.
I do right. Okay, thank you.
Thank you so much. I like the spirit of trying, and just to assure you, whatever I tried is very correct. I'm glad you understood the commands and the way you're articulating how we are merging the different data sets. I think that is great. So we are going to, since we've had Mona to present to us what she has presented, I highly believe that we've been all following how to emerge using the left join, using the right join, the inner, and then the full join, the way she was elaborating. Can we get only one more person? Maybe there's something you want to add, and then we'll proceed. Oluwapenel, I don't know if I'm pronouncing the name well. Please unmute and share, and then we start. If I've not pronounced your name well, you can help me to pronounce it right.
Okay. My name is Ife, and Muna has done the work well. I'm actually using two devices. I'm using my phone and I'm practicing with my laptop. I'm trying to share the screen on my laptop. But I did exactly what Muna did, except that I didn't do the full join.
Okay. Okay, fine.
I don't just do the job.
Sorry?
Okay,
that is. Are you sharing?
I'm finding it difficult to do. But please, can we proceed?
I can't hear very well. I don't know. Are you sharing your screen? Dr. Thomas,
is not.
No, there was some technical problem, but now she can you start now?
Okay, let's proceed. Now, what we are going to do today, yesterday when just a recap of what we did, we looked at how to download and then install R and R Studio on our computers. We went ahead to learn about the different levels of measurements, then importing data into R, depending on how the data has been saved, and we looked at the different ways of how that data can be imported into R. And we also had a comment that says that R can can work with other softwares. In case you've got data that is saved maybe in Stata or SPSS or SAS, you can still import that data into R. So yesterday we closed when we had looked at the theory bit, and we wanted to go through data manipulation practically using R. So it's the bit that I'm going to recap on. It's a bit that I'm going to go through, and then Professor Susan will come in to give us what we are supposed to have for day 2. So I'm going to share my screen. You can also do the same where you are. Open your R Studio, and then ensure that we're still using the same data set. The data set we had yesterday for work salaries is the same data set we're going to do and try to do what happens in data manipulation, the things that you want to do. If you check in your PowerPoint, the one that we're using yesterday, and I clearly remember we talked about that within data manipulation, you can do a lot of things, and everything depends on what exactly you want to achieve at the end of the day. For example, we talked about creating new or adding variable in your data set, recording of an existing variable, renaming a column, or you want to delete a column, then the levels of measurements and merging data. I'm glad that Mona has been able to explain the merging data very well, so I will not go through that. So what was always, the moment you've got your package, for example, like yesterday, we installed our packages. So what we are going to do today, we do not need to install them again. We are going to just load the packages that we need so that we continue with the manipulation. I've highlighted all my packages and then I run them, because remember, these are the packages I've got inbuilt functions that are supporting us to write our commands very well and do the manipulation that we want. So in case I load my libraries, please, when you look in the console, there is a stop button. That red button comes the moment you're running a package, and the moment it is successful, the red button will disappear. So we looked at that yesterday. I'm loading my packages that with the work. Again, yesterday, we looked at how to set the working directory using various options. And it also depends on where your folder is saved on your computer. So I did not change my folder. I'm only going to run the set directory line such that now I don't need to go through the process I had. Since I saved the command, all I need is to run it. And the moment it agrees in the console, then it implies that my path is correct. Okay. Remember, I'm using the worksalaries.csv. So I use the CSV command. I labeled my data set salaries. Please also do the same such that we move on the same page. So when I come there and I check in when you check in the environment, the global environment, I can see that my data set has been successfully imported salaries with 397 observations and 6 variables. All these are commands that are in the salary R script. We looked at them yesterday. So I'm going to scroll down, and I want to, the part of the structure, the categories that we talked about, they're really very important. So I'm going to run my lines telling R that rank is a category, discipline, and then sex. And I can also check the structure of my data set, all the things we looked at them yesterday. And now I can confirm that, yes, the way R has stored my data, it is the way I want it to look like. Sometimes you might be interested to see the summary of your data set in everything together, where you get, in case of continuous variables, you'll have a summary statistics from minimum to the maximum, and then the categorical ones, they will give you the frequencies. So now I'm going to move on to data manipulation and go through in case what happens in case you've got a data set and you want to manipulate it according to the objectives of your study. So let me check in the chat. Please import the data, and then have you managed to import the data successfully in R? Import the data in R, and then type for me yes if you're done. We need to work together. As I work, you also do the same, okay? Okay, I'm seeing people are telling me in the chat that they have been able to import their data. If you've imported Excel, there's no problem, it's the same thing. But remember with the one of Excel, it will give you a name called work salaries. By default, it's what it will save for you. So where there is salaries, you can change it to work salaries, or you can rename like the way we are going to see. So the first one, we say that we can create new or add variables. Sometimes you can have a data set, but within that data set, you can create another variable, a new variable. Remember, our data set is salaries, assuming I want to create a new variable called half salary. So how at the back of my mind, I need to ask, how do I get half salary? Implies that I need to go to my data set and then consider the column which has got salary, okay? And I divide everything by 2. So it is what I did on this particular line that you're seeing. Half salary is my new variable. And I'm starting with salaries because I want this column, the new column I'm creating, or the new variable I'm creating, to be part of the main data set. The salaries there. So it is salaries, $ half salary. And I'm assigning it. Remember, we looked at how to assign a variable yesterday, or in this particular case, an object name half salary. So I go to my data set, salaries, and I pick only the salary variable. I get and I divide everything by 2. So it implies that now I'm going to come up with a new variable. So in case I run this particular line, if you look in the console, it has successfully run. And when you look in the environment, I'm seeing something new, that instead of now having only 6 variables, I've gotten 7 variables. In case you want to view, you can come and click on the Excel icon. When you click on it and you move, you're going to see that now you've gotten another column. There are no longer 6 variables, but now you're having 7 variables, with a 7th being half salary. So it went ahead and took this particular column for salaries and divided by 2. Of course, it could be maybe other complex variable that you want to create. It doesn't matter. But the point is getting the basics first. Number 1, creating new or adding a variable in the existing data set. Now, number 2, about recording an existing variable. Okay, what we are going in this particular case, I still wanted. Remember what I said, that depending on the objective that you want to achieve by the end of the day. So how do I re-record an existing variable? For example, in case at the end of the day, I want to look at people who belong to a low category and then high category of salaries. So in this particular case, remember, salary is a numerical variable, and I got its summary statistics. You can as well run only a particular variable from the main data set. In this case, it's salaries, $salary. When you run that, the results that you're going to get down here in the console, you only see now the salary variable. You don't see other variables. But in case you had put salary in bracket, summary in bracket salaries, it will bring you a summary of a full data set. But in this one here, what we did is we got only one variable. Okay, and I am given since it's a numerical value, I'm given a summary statistics with the minimum, the first quantile, median, mean, the third, and then the maximum salary. So from here, I say that, can I use my mean as a threshold such that I'm able to categorize those who get, and I'm assuming that in case somebody gets below the mean, that is a low salary. If somebody gets above the mean, that is a high salary. So it is then, so how do I do that? I further go ahead and create another variable, which I termed as salary cut. Remember, my main data set is salaries. But in case I want to add another variable within the same data set, I need to add it there. So I'm saying that within my main data set salaries, add for me another variable which is called so I use the element, the if else. This is what I use, okay? Because I want to create two options. Those that belong to the low salary and those that have got high salaries. Like we mentioned yesterday, you can use the hop command to support you to understand what a particular command means, to give you more argument on how you can go about it. So I come in here, what I start with is the test that I want. So this is the test the code salaries and pick for me all whoever has a salary that is less than the mean, which mean is 113706, and categorize those as low. This is the first bit, okay? Label them as low. So, and since it's if else, so it is a logic, it is a logic, then label the other people high. So this is the high bit. We have got two groups, the low and then the high. Those who are below the mean, they're going to be labeled low, and those who have above the mean, they will be labeled high. Remember, sometimes maybe, for example, as we are going on and look at that we have two outputs, two binary. You have a binary output, a yes or no, and it's the same case that can work here, where you have low or high. There are two outputs. So in this particular case, a binary logistic regression can work. So in case I run this particular line, I expect my number of variables to increase. So if I run that line, when you check in the environment, the variables are increasing from 7 to 8. And when I check in my console, it is telling me that it has successfully run. I can be able to check, I can be able to view, I can click on the Excel icon and I check whether the salary cut variable, it's now part of my main data set. When you look here, we are having another salary cut, and it has got two levels. It has got the high and then the low. So in this particular case, in case you want to get, for example, a summary, you're going to come up with the number of those who belong to the high category and the number of those who belong to the low category. Okay, that is great. So that was re-recording an existing variable. So it implies that from one data set initially, whereby it was just a continuous variable, we would use multiple linear regression. But the moment you re-record it into a categorical, then it implies that the method of analysis also has to change. Okay, let me check in the chat. Are we on the same page? Are we on the same page? Okay. In case you have a question, kindly share it in the Q&A, and then you'll be helped. So now let's proceed. What about in case you want to rename a variable? Okay, renaming columns. Remember initially when you check the structure, okay, I can check the structure of salaries. Usually what we know about the structure, it gives us the different variables in your data set. So this time around, when you come to the structure, what we are seeing, it is giving us, we have 39 observation and 8 variables. And right now, I guess we understand why we are having 8 variables. So our data set has increased. However, when you check again on the salary cut, for us, we are saying that it is categorical in nature, but R is seeing it as a character. So in case maybe your objective to use salary cut as the dependent variable, you still have to go and use as a factor such that R changes the way it is seeing the salary cut into a categorical value. All right. So now these are the variables that we are having, and we want to rename. Assuming maybe you want to rename the variables, we can change. Maybe you want to rename sex, or you want to rename years of service and you put experience, or you want to rename discipline and you put maybe area of specialization, all those things can still apply. The concept remains the same. So we use what we call the rename command. Okay, we use the rename command, but remember everything emanates from the salaries data set. So what we do using the rename command, and then inside rename, you start with your data set, which is salaries. And then after that, you put what you want to variable you want to rename. For example, in case I wanted to change sex to from which is in small case to uppercase, then I could write what I want that change this into where there is SEX, change it to capital X. Or somebody else can say that no, it's still within my data set, salaries. I can go ahead and say rename. Rename is the command. And then inside, if you very well, rename with the data, okay, you can still check and see, how do I use rename? You start with the data set, then you say salaries, okay? Salaries is my data set. And maybe you can say you want to rename, let's say, you want to, instead of years of service, you want to put experience, okay? And you say, where you rename, where there is years of service, you put experience. So that's what you can do. So in case you run the first line, you run and check, you see that it has successfully run. So I expect in case I check the structure again, whereby my sex with a small case has changed to sex with an uppercase. And then in case I rerun my second line, I expect where there is years of service to have changed into experience, okay? I can check the column names by using the call names of the data set because I want to check, has it changed? You can as well move to the main data set by viewing. If you can see very well, here we had years of service, but now it has changed to experience. And then where we had sex with small case, now it is in upper case. In case you don't want to do that, you can go ahead and use call names. Call names implies that you want to see the names of your data set, salaries, and that is the command that we can use. So in case you run this particular line, then what you're going to see that, okay, now I have experience what I've renamed, and then I've also renamed the sex with the uppercase. So that is another way on how you can manipulate your data. Maybe you want to replace the variables to names that you feel that you can quickly use throughout the analysis, whereby you don't forget them. Okay, great. Now let's move on to another way on how you can manipulate data. You can subset rows or columns, all right? But in this particular case, I'm going to use the rank variable. Remember initially when we took the summary of the whole data set, we were able to, when we came to categorical values, we are able to see how many the number of respondents that belong in every level within a categorical variables. So with the subset, I want to use the rank and see. Maybe within this particular rank, like we saw yesterday, we had an assistant professor, an associate professor, and professors. Like the way we are saying that as we are discussing, try to shift what we are learning to your data set. So what is happening here, assuming that within my particular data set, I want to work with professors only. Maybe I'll look at other levels later. So what we do, we can use the subset command. The way you hear the word subset, you're trying to pick something out of the main data set. What do you want to subset? So we start with the salaries, our data set within the argument. So what we start with. And then in the argument, you can include what you want to subset now. So you tell R that go under the rank variable and pick for me only professors, implying that now in case I view my data set again, I don't want to see other levels or attributes that we talked about. I only want to see only one category of people. I still say this one can work maybe if you're having a certain crop that you're working on and you've gotten various crops that you want to study. But in case you want to study one crop in particular, you can subset it from the rest of the other crops and then do the analysis. And then later, maybe you can study how the rest are related to what you've studied. So remember, for you to see the numbers or the frequency for a categorical value, we use what we call the table command, okay? Apart from the summary, remember there are various ways that you can use. So you can use table and then you run this line. If you check in the console, table salaries, salary is my main data set, but I specifically want to pick rank. Table only works with categorical variables. In case this one can also work with, it can also work with the discipline, where we've got humanities and then sciences, and then it can also work with the sex, where we have female and then males. But under here, I said that when you look in my console, I've got 64 associate professors, 67 assistant, and then 266 professors. And then I say that now I only want to work with this, with only this group of rank that belong to professor. So what I do, I said we use the subset command. But now this time around, since you're getting a portion or a fraction of the data set or from the main data set, you need to rename your data set. So what I say, now I'm going to rename, instead of salaries now, I name it salaries prof. Okay, implying that the data set now I'm going to get, it only contains professors. And what do I expect? For me to predict that I'm right, I expect to come up with 266 observations. In case it's more than that, then it implies that there is a problem with my data set. So in case I run this particular line here, okay, if I run it, I check and see that now I've got a new data set called salaries prof. Okay, and under here, it is true that I'm having 266 observations of my 8 variables. You can click on the Excel icon and this time around and check. When you look in this particular column, it is only the ranks that I'm seeing. I'm not seeing any other rank. So it implies that now I'll be able to have this as my other data set, which I can what? Which I can work with. Okay, let me check in the chat. Are we on the same page? In case you missed yesterday, please refer to the YouTube that was sent. Check the YouTube that we used on how to install and download. All those bits are there. We are not going to go back today. Okay, great. All right. So now that is one way on how you can subset or get a fraction of your data set, and you'll be able to see that. Okay. What about in case you're having a data set, after manipulation, you want to delete some bits. You want to delete certain columns. For example, in this particular case, maybe the new columns that you have, we have salary, we have salary cut, and you want to delete them such that you go back to the original, data set. Still, we use the subset. We still use the subset command, which I'm having here. Remember, what do we start with first? It's our data set. You put in the name of the data set, and then you use select. Select implying that from the main data set, remove for me this particular variable. Okay, select is equal to minus. The minus you're seeing in front of C, it is remove, minus from the main data set, minus for me this particular variable. So inside here, inside the C, you're minusing the variable that you want to be deleted. It could be one variable, or you can have multiple variables, more than 2 or 3 and so on. So in case you're having more variables other than one, like in this particular case, what we did, we had that you remove half salaries. So in case I run this line and I check back again, you see that now my variables have reduced in the environment. I can still view and see whether that one has been deleted. Still, you can check that now salary, you can now check that half salary variable, it has been deleted. You can as well see in case in this second line, I'm still doing the same thing, but what I'm doing, I'm trying to show you that you can delete more than one variable. So now I'm telling R, delete for me salaries and also salary category. I'm no longer interested in them. So I come and I run this line and I check again. I see variables have now reduced to 5. I can as well view, I see rank, discipline, yes, since PhD, and then that, okay? That is how you can work with subsetting your data set, but everything goes back to the objective that you set from the start. The other one is level of measurements, which we discussed yesterday. We talked about how to deal with missing data, and then Mona has discussed emerging a data set. I'm not going to go through that because it has been already discussed. So now the last bit on descriptive statistics, which is also important, and then Professor Susan is going to start. I want to read back my data set to do some descriptive statistics, and then we go on. Because while I'm reading back, remember, I've deleted out some of the columns, yet I need them to see how do they work in a descriptive statistics. So in case I read my table again, I can check that now I'm getting my original data set, that the one that I had in with respect, you can use a set. We've already seen that whereby R has got inbuilt commands. For example, in case you want to get the within the summary, we're able to get everything at once using the summary command. But you can also run particular bits if you're interested in them. Like here, I'm saying that I want R to give me the minimum of salary. Remember, salaries is my data set, and then I want the minimum of salary, which is the column that I've called for. I'm asking for the maximum, I'm asking for the mean. I'm putting everything on one line, putting them with full columns, okay? And then I can also get the standard deviation. And the same thing can apply to other variables. So in case I run that line, it will give me 4 outputs. The first one will be the minimum, the second one as the maximum, the mean, and then the maximum. All right. So now I've already mentioned that in case you run a categorical variable, we use table. So the moment you run the table, you get table command. Within the table command, call the variable that you want to get, okay? And then it will give you the number of frequencies. For example, here I've put table salaries. I want for the rank, for the discipline, and then for the gender. So in case I run that, it will give me my in the output in the R. So then the subject of discipline, I'll come up with A and B, the humanities, and then the B, the sciences. Then with sex, I'll see 39 female, and then 358 males. Remember, table command works for only categorical variables. Now, in case we move on, after getting the table, sometimes it is important, especially if you're going to report your data and you want to publish, to quote the frequencies. And I know I've already run the part of a table into salaries and then rank. However, I can store the whole of information into an object which I'm calling ranks. Okay, I can store the whole of this information into a variable I call ranks. Remember what we said, that you can assign a variable. So in case I say that I want to store everything in ranks. So I come here and I say, this is an object I've created. It can be any name. An object can change, it doesn't matter. So let's dash table, this one here. Okay, so if I run that particular one, what I'm seeing that in my console, I'm seeing ranks, less dash table and so on. I'm not seeing the result. So for me to see the results, I need to run the object itself. The moment I run it, I'm able to see the results. I can further go ahead and get the percentages or the fraction by using the prop.table command. And inside now, I put in my object. So when I run that line, what I'm going to see is that I'm given the percentages, the fractions. For associate professor, it is 0.16, for assistant, 0.168, and then for professor, it's 0.67. Sometimes in case no sound, I can't hear. Okay, can you hear me now? You can? Okay. So sorry about that. Let's continue. So I was saying that you can round off, okay, by using the round command. When you look at where my red short is, it has got inside what do you want to round off. So it's what you start with, then comma, digits equal to 0. Where you're saying digits equal to 0, it implies that put the decimal places that you want. Okay, so in case I run this line, now I'm getting the percentages as well as they've been rounded off. Okay, so we can have that. And then the other part on data visualization, what we can do, it still depends on the nature of the variable. If it is categorical, like we mentioned earlier, you can use a bar plot, or you can use a pie chart. If it is numerical or continuous in nature, you can use a histogram or a scatter plot. Prof is going to come in with more details on exploratory data analysis. So here, remember I had this before when I was calculating the frequencies, the table command. Inside the table command, I asked for salaries, and then from the salaries data set, pick for me rank only. which I saw earlier that I had with my frequencies, I had associate with 64, assistant with 67, and then prof with 266. So I want to plot a bar plot and see how it looks like. So in case I plot, remember yesterday what we said, you check everything in the plot window. So if you zoom out, I don't know if you're able to see this. Are you seeing my plot? You're seeing it now? Huh? Okay. Now, when you zoom out, this is what we are able to see. These are frequencies. Remember, I've not plotted percentages, but also the percentages are possible. And we see that now we are able to view graphically the rank category. Within R, you can as well go and label each bar, maybe with the number of frequencies that it has, or if you've used percentage, you also indicate that. Okay, so I'm going to share my R again and then continue. Sometimes, in case you're having many plots in the plot window, you can also delete them off. You can clear the plot window by typing dev.off, in bracket, you don't put anything. So in case you run this particular line, remember in the script that you have, I put some of the comments so you can always read. And I say that this command, what it does, it removes the current figure from the plot. If I run that, the figure will be cleaned up. You will not see it anymore. And there, of course, when you're doing data visualization, there's a lot of things that you can do. How you want your plot to look like. Do you want it to look horizontal, or you want it to look vertical, like the one that we had previously? So now, on this particular command, I use the same plot that I had up here, but I said I put another argument, horiz, implying that it is horizontal. So this time around, I want a figure that is horizontal, and then I said equal to true. Initially, we had the one that was vertical in nature. So in case I run that command, in case I run that line, you see that if I zoom out, so let me share what we are getting. So I think I've closed it. Okay, if you zoom out, you'll be able to see that our figure this time around, the direction has changed. This is what I'm, if you change the structure to now horizontal, this is how you're going to see how your graphics is going to look like. But still you can see that it's the same information. What you've changed is just the axis, and you would see the rank on your y axis, and then the frequency on your x-axis. And you can still go ahead in case you want to change the colors. If you want to change the colors for each, you can also go ahead and put in a lot of arguments, labeling the axis, putting the title, and so on. All those things can be done in R. The point is getting the basics, and then the rest we just need to build on. You can as well do the pie chart. You'll come up with the same thing. And then lastly, in case I'm to consider for the case of a continuous one, like for the case of salaries, we use the plot command, which we are having there. And I'm plotting salaries because it is a continuous variable. And we're going to come up with a scatter plot. You can run that, and then always remember to zoom and you check and see how your figure looks like. The moment you zoom, you are able to see how your variable looks like. So in case I share that, what you're seeing now, it is a scatter plot for salaries. We are seeing that how the salary variable is being spread all over in a scatter plot. And of course, you can come up with different conclusions, or you want to fit a regression on it, and you see whether it is giving you the desired results. So let me go to the last bit, back to the R Studio. If I'm to scroll down, we say that you can as well, within your command, you can put in other arguments. Like in case you use main means title. You can say main equal to, you put in the title that you want. You can even color the title in case you're interested. You can as well run a histogram in case of a continuous variable. In this particular case, the command is hist, H-I-S-T, and then in bracket you put what you want to draw a histogram for what. In this particular case, you're saying, go into my salaries data set and plot for me salaries. So you get this, and then at the moment you run it, you will be able to see the plot for the histogram. So in case I stop sharing that, and then I share what we've come up with. So this is how you're going to see the histogram for for salaries. If you don't want a scatter plot, and then you see where the data is mostly concentrated. So I can stop sharing that, and then I share my R Studio again. So basically, I'm coming to the end. Now, given that we've looked at the starting bits of data of descriptive data, and we've done we've done data manipulation. Sometimes as you're manipulating your data, maybe in case you want to retain the new variable that you've created, and you want to create a new Excel file sheet such that you use it again. So what we are going to do in that particular case, we use what we call the write.csv command. What does it do? The write.csv command exports data from R to Excel. Initially, when we're importing from Excel to R. Now, what about in case after data manipulation? You've created some variables which you have to maintain. So but now you want to return this data into an Excel. So what we do, we use what we are exporting now from R to Excel, and we use the write.csv command. The write.csv, what do you start with? You start with the name of the data set. After the name of the data set, you go on to the file name. What do you want to call it? So here you can say, I want to call it salaries.csv. So if you run this particular line, after running it, you go back to the folder where you had set your working directory and check and see whether the file salaries.csv is there. Then that one implies that is the new data set that you've created. In other words, you've been able to import data from R to Excel. Okay, I think that marks the end of the bit that I wanted to cover. The other bits, we can follow them, the Control L and then the list. Okay. Any question? Could you show us how to add the equation in the regression line? We are going to see that. So you just need to be a little patient. So I'm going to give you a break of 5 minutes. Okay, I'm going to give you a break of 11 minutes and then Professor Susan will take over. Okay, somebody's asking that. Please share as the R script. Okay, somebody's asking about a recap on a bar plot. You do it, eh? Okay, that particular bit, more details are going to be covered by Professor Susan under the descriptive, the exploratory data analysis. So please just hold on. After 10 minutes, she's going to join in, and then we proceed from there. Thank you.
muted. Good morning, participants. Good morning. Can you hear me? Somebody is saying what happened to the sound. Can you hear me? Okay. Okay, let's start. I hope you've had a good break, and I would like to thank my colleague Helen for having taken you through the R programming language. We are going to go into exploratory data analysis, and after this, my colleague Thomas Odong will come in, if time allows today, if not, tomorrow. So some of the things that we are supposed to cover here, practically she has already done them. So when it comes to practical part, we will be perusing through, we'll be just recapping. Okay. Okay, so we are going to look at exploratory data analysis. And exploratory data analysis is aimed at summarizing the main characteristics of the data set using either numerical or graphical methods. It's a critical step in analyzing data because then you're able to see what is happening to your data before you do formal modeling and hypothesis testing. Exploratory data analysis was promoted by John Turkey in 1970, maybe before most of you were born. And this was meant to encourage statisticians to explore the data and possibly formulate hypotheses that can lead to new data collection and experiments. So wherever you have data and you've collected your data from the field, or you've collected secondary data from any source, then you have to do your exploratory data analysis to see whether there are trends, to see the magnitude, to see differences between groups. So that is exploratory data analysis. The importance of exploratory data analysis, it is to maximize insight into a data set by uncovering underlying structure. So in this underlying structure, we are able to see whether there are relationship between variables, the type of relationship, is it a linear relationship, is it a curvilinear relationship, is it an unlinear relationship, etc. So it's only through exploratory data analysis that you are able to view these types of relationship. We are able to extract important variables and create new ones, and also do data transformations. So when you plot a scatter diagram, you're able to know whether the data has a linear relationship between two variables. When you construct a histogram, we're able to know the distribution of the histogram. And if it is non-normal, you can now decide whether you're going to do data transformations or not. And then through exploratory data analysis, we are able to know whether our data is highly correlated, and then we decide to create new variables using multivariate data analysis, using principal component analysis. So by doing that, we are reducing the correlation from the original data set and creating new variables. But it is through exploratory data analysis. Then we are able to detect outliers and mistakes. Outliers are values which are different from the rest of the data set. So those values can either be by mistake or they are genuine outliers. Outliers affect the estimates of our parameters. For example, the estimate of mean is highly affected by outliers. If we have, for example, we are looking at income of people in our country, and most of the people are poor, that means that the average income is going to be skewed to a lower end So it will appear that most of the people in the country are earning very low, yet it is because of the outliers. There are very few people who are earning very little that have affected the average value of income. You're able to know your mistakes. Maybe you have entered your data wrongly. You're able to come up with those mistakes and then correct them before you do the formal analysis. We are able to test underlying assumptions under which all our statistical inferences are based. For example, we've already talked about histogram. When we construct a histogram, we are able to know whether the data is normally distributed or not. And most of these statistical inference, we assume that the data is normally distributed. We are also able to know whether we have increasing variance or not, using plots that we'll look at when we are talking about regression and experimental design. Okay, we are able to support the selection of appropriate statistical tools and techniques. Once you do exploratory data analysis, if originally you had said you're going to do analysis of variance, and then you find that actually the relationship between the response and the categorical variable you have is a linear relationship, it doesn't require you to run an ANOVA and experimental design, then you end up running a regression. So that's what exploratory data analysis does. Okay. So we find that the type of exploratory data analysis depends on various methods. We have the method of summarizing data. Either you're going to use the non-graphical or the graphical methods. And then we have number of variables. Are you only looking at one variable at a time, or you are looking at many variables, which we call multivariate? And if we are looking at one variable at a time, we call that univariate. So if you have, for example, height, and that is what you want to look at, you want to look at the height of various plants to find out whether there are differences. You're going to look at one variable at a time. How about if you have very many variables? You have height, then you have collar diameter, you have number of leaves, you have several variables, and you all want to look at those variables at a go. Then we will use the multivariate type of summary statistics. We also see that under these two, the non-graphical and graphical methods, there are various types of summary statistics that we can use or exploratory data analysis. Under non-graphical, we have what we call measures of location. And these ones are used to locate the average, the median, the mode. Then we have also measures of spread, which tell us how far the observed values are from the mean, which include the range, the variance, the standard deviation, interquartile range. We can also summarize our data using frequency tables. The frequency tables tell us how many groups you have in your data and their frequencies. Under univariate, we can also do some graphical methods, which we are going to see in details. We can look at a box plot, we can look at a histogram, a stem and leaf, a bar graph, or a pie chart. All those depend on the objective of analyzing the data. Okay? Then under multivariate, we can do cross-tabulation between a qualitative variable and a quantitative variable. Or we can do cross-tabulation between two qualitative variables, which we are going to see in details. We can do covariance correlation matrix, and under the graphical section, we can construct a scatter plot, which you've already heard of. And in a scatter plot, we are able to establish relationships. We can construct a bar graph where we are able to know which particular category has the highest frequency. We can construct a histogram, which helps us to know the distribution of the different variables. And then a box plot tells us the distribution as well as which group or which variable has the highest median. Okay? So we are going to look at this in details. Then also the type of variable determines the choice of summary statistics. So the choice of summary statistics depends on the type of variable we are dealing with. There are two major types of variables. We have the qualitative and quantitative variables. The quantitative variables are also divided into two. We have the discrete and continuous variables. So if measurements are integers obtained by counting, then those measurements are called discrete. For example, number of people in a household, number of cigarettes smoked per day, number of participants in this course, number of trees, number of plants, all those are discrete in nature. Then continuous variables consist of measurements that can fall within a range or values obtained by measuring. For example, weight, height, length, all those are continuous variables. So when you're writing your proposal, you're able to actually know the type of variables you're going to collect, and you're able to associate the type of analysis that is likely to be performed when you collect your data. Okay? Then we have the qualitative variables. The qualitative variables describe characteristics or attributes of an individual. And they can be categorized either as ordinal or nominal. Nominal variables are associated with some quality or characteristics or attribute which a variable consists of, but they do not have a natural ordering on them. For example, color. If we look at the different type of color of hair, we have people who have brown hair, others have red hair, others have black hair, maybe some have green hair, depending on the likes of people. But the order does not matter. Vehicle type, there are various types of vehicle, but order does not matter. If you have a Ford and another has a Toyota, and then you put a Ford first and Toyota second, the order does not matter. So when you allocate names to characteristics or attributes of a variable, then we end up with a nominal variable. When the names are related to some natural ordering, then we call those that ordinal variables. For example, height, short, tall, average. So we can never call a short person tall by the fact that the height of that person it falls in the short category. Then if we look at taste, if you're given two types of biscuits, one which is sour, another is sweet, there is no way you're going to call the sour biscuit sweet. Automatically, because of your taste buds, you call it a sweet biscuit, another one will be a sour taste. If we look at temperature, we have high temperature, low temperature, moderate, and then zero temperature, which is cold or very hot. So you can see that the way temperature is categorized depends on the magnitude of the temperature. That is the natural ordering attached to the categories under that particular variable, which is ordinal. And the order matters. If it is high temperature, there's no way you can shift and call it low temperature. Okay. Okay, in the chart, any question? Any question in the chat? Can I see in the chat? Any question? Okay, none. Okay, so let's proceed. Okay. Okay, thank you. Let's proceed. So we have a data set. I have already sent it in the Google Drive. It's called employee. And we would like to describe that data set depending on what we've already learned. So that data set consists of variables: gender of employee, male, female; educational level, that is number of years at school; job category, we have 3 categories: cleric, custodian, and manager; current salary in US denomination; beginning salary still in the US denomination; time on job in month; previous salary in years; minority categorization, it's a yes and no. So from these variables, can we identify quantitative variables in the chart? Can you name the quantitative variables among these variables that we have in our data set, which we are going to use? Which of these variables are quantitative in nature? Let me see in the chart. Okay, current salary, okay, experience, beginning salary, experience, number of years, time on job. Okay, okay, thank you very much. And among the quantitative variables, which one is continuous? Among the quantitative variables, which one is continuous? Okay, salary, current salary. Okay, experience. Okay, thank you very much. And among those variables, which one are nominal? Among those variables, which one are nominal? Okay, we have gender, yes, gender, minority, yes, okay, gender, minority. Thank you very much. Thank you very much, participants. That is really excellent. I am so excited that you know what is happening and you're so attentive. Thank you very much. So we find that gender of employee is nominal because those are just names, male and female. Educational level, number of years at school, number of years at school qualifies to be quantitative. Job category is also nominal because they are names and the naming does not have a natural ordering. Current salary, beginning salary, they are also continuous in nature. Time on job, they are continuous in nature. Previous experience in years. And then minority categorization is nominal. Okay, so knowing the type of variable also helps you to know what type of summary statistics or exploratory data analysis we are going to apply. Okay, so the data set looks like that. Is it visible at your end? Is this data set visible in the chart? Okay, okay, great. Thank you. The data set is visible. It consists of gender, the birth date, years in school, job category, current salary, beginning salary, time on job, previous experience, then minority. So we are going to use this data set to do our exploratory data analysis. So we'll first of look at summarizing a quantitative variable, and we'll look at one at a time. So in summarizing a quantitative variable, we can use a box plot. A box plot consists of a 5-point number summary. It consists of, you can see this line here, the topmost line, before you see the dots. The topmost line, which is named upper whisker end. This value here is the maximum value. And when I lower down my cursor and go to the box, the first line here, the first edge of the box, which is named Q3, or upper hinge is the third quartile. When I move to the dark black line, it is called the median. When I move down to the end, the edge, the first edge of the box, it's called the first quartile. And when I go down to the line, this is the minimum value. The difference between the third quartile and the first quartile is called the interquartile range. These dotted lines are called whiskers. There's an upper whisker and a lower whisker. So the box plot is called a 5-point summary. The point you see here is called an outlier, but we can always confirm that this is an outlier using a formula, a simple formula. Okay? So that is a box plot. What does a box plot tell us? It tells us the distribution within that variable. So within the variable, if we look at that box, we can know that either our data is skewed to the left, to the right, or normally distributed. Now, if the box plot from this line here, the maximum to the minimum, if this upper part is not equal to the lower part, then we know our data is skewed. So if you look at our box plot here, the upper part is longer than the lower part. The upper part represents the right-hand side of the box plot. The lower side represents the left-hand side. So this right-hand side is longer than the left, meaning that if this was a real data, it would be skewed to the right, because the right-hand side is longer than the left-hand side. Now, if these two parts are equal, then the data is normally distributed, or we call it symmetric. If this left side was longer than the right side, then we call that a left skew. So that is the 5-point summary, the box plot. We can also use it for more than one variable to compare between two variables. Look at their average values. Are they different? Are they the same? Is the distribution of variable 1 the same as variable 2? And we can also identify outliers using a box plot. So we've already seen the quantitative variables. We won't repeat that. So the ones highlighted in blue are quantitative variables. So we want to summarize educational level. So if you can see in the table here, we have our minimum number of years spent in school is 8. The lower quartile is 12. The median is 12. The upper quartile is 15. The maximum is 21. So the least educated person in that company has spent 8 years at school. So in our current setting, if somebody has spent 8 years in school, that particular person should have finished A-level. Okay? Now, the maximum number of years spent in school is 21 years. So you can imagine that person who has spent 21 years in school should have done a master's degree and probably even a PhD. Okay? So the average number of years spent in school is 12 years, meaning that that person has already done O-level or he has not yet done undergraduate. Okay? So you can see that this particular information in the table can be summarized in a box plot. You can see the maximum value, then we have the upper quartile, the lower quartile, the median and lower quartile are same value, 12, 12. Then the minimum value. We've already seen that the interquartile range is the difference between the upper quartile and the lower quartile. The formula you see here, it's upper quartile plus 1.5 times the interquartile range. So this formula here is used to find out whether the values above this value are outliers. So if we substitute UQ plus 1.5 times the interquartile range, our UQ from the table is 15 years. Our interquartile range is going to be 15 minus 12, which gives us 3. Okay? So if we substitute in this formula, here, UQ, you see it here, I hope you can see it. It's UQ plus 1.5 times interquartile range. So if you substitute, our UQ is 15 plus 1.5 times the interquartile range, which is 3. So this is 15 plus 4.5 gives us 19.5. The maximum value is 21. So any number above the value we've just calculated, 19.5, is an outlier. So the maximum value is an outlier. So you can see that in the box plot, it has been highlighted as outlier. Any value above the value you get with this formula, UQ plus 1.5 times interquartile range, is an outlier. When we go to the lower end, we put in, instead of UQ, we put in the lower quartile minus 1.5, excuse me, 1 minute. Okay, excuse me, participants. Okay, on the lower end, we want to find out whether we have any outliers. The formula changes. Instead of UQ, we use LQ. LQ for lower quartile minus 1.5 times the interquartile range. So if we substitute, LQ was 12, the lower quartile, minus in bracket 1.5, our interquartile range is 3. So we'll find that 12 minus 4.5, we will get a value of 7.5. So our minimum value is 8. Any number below 7.5 is an outlier. Our minimum value is 8. It's not an outlier. Okay? So is there any question about finding out about outliers? Let me see in the chat. Today's working material has already been sent. Let me request my colleague to post the, my colleagues are going to post the link, the Google link. The information is there. Okay. So somebody says that I should repeat. Can you explain the lower part? Okay. So the lower part here, the formula should be LQ minus 1.5 times interquartile range. That is the lower end. So any number below the value you get with that formula is an outlier. So in this case, in our example, the LQ is 12 minus in bracket 1.5 times the interquartile range, which is 3. So the value we get is 12 minus 4.5, and that gives us 7.5. So any number below 7.5 is an outlier on the lower end. So in our box plot here, we do not have outliers on the lower end. Okay? On the upper end, we already know the formula. Any number above that value is an outlier. That's why you see the maximum value is an outlier, because the value we got with this formula was 19.5 and our maximum value is 21. So any number above 19.5 becomes an outlier. So when you see outliers, you don't just delete them. What we do investigate, are they genuine outliers? If they are genuine outliers, we leave them in the data set, analyze our data with the outlier in, look at the magnitude of our parameters, and then analyze the data without outliers. Look at the magnitude. If those two values, with outlier and without outliers, are changing suddenly, for example, if we calculate our average value, average number of years spent in school, and we find that with an outlier, the value is, for example, I'm just giving an example, 16. Then without outlier, the value is 12. That means that that outlier actually is extremely affecting our parameter of the mean. Okay? We can even test that difference. Is it significant? Should we go ahead and delete our outlier? Using a two-sample t-test, you can actually test the difference between the data, the parameter you get with an outlier and the parameter you get without an outlier. If the two values are not significantly different, then you go ahead and analyze your data with your outlier. So I'm going to repeat. If you find that you have outliers in the data set, you can analyze your data with your outlier. You record your parameters. Then delete the outliers. Analyze the data without outlier. Record the parameters. If we find that the difference between the value with outlier and without outlier is significant, then we use the data set without outlier. If we find that there are no differences, then we leave the outlier in and go ahead and analyze our data. Okay, let's go ahead. So that was about the box plot of number of years spent in school. How about current salary? We see that the minimum current salary is $15,750 US. The maximum is 135,000. That is an outlier. We can find out actually whether it's an outlier. Let me find out from chart. Is the maximum value, the maximum current salary, an outlier? Can you compute that? And we see in the chart. Is it an outlier? Is the maximum value, which is 135,000, an outlier? We have the formula UQ plus 1.5 times the interquartile range. Can we see in the chart? Let me see in the chart. Is it an outlier? Okay, I have a question. I will answer it later. Is 135,000 an outlier? Let me see in the chart. Work it out. What value do you get? What value do you get? What are you comparing with? We know that so somebody says this is an outlier. Okay, our upper quartile is 37,050 plus 1.5. Now the interquartile range is 37,050 minus the lower quartile, which is 24,000. So you fill in that value. I'm also working out. As you work out, I want to confirm what you're saying. Okay, I've gotten a value of 56,625. That is the value which I have gotten which we are going to compare with 135,000. And we see that 135,000, thank you, Monday, we've gotten the same value, yes. It is higher than the value we use to determine whether there is an outlier. Okay? So that maximum value is an outlier. Is it a genuine outlier? Yes. At one time T, this company was paying their manager 135,000. That manager must have brought in a lot of business. So that's how we investigate this outlier. Is it genuine? Yes. Why? Should we analyze our data with this outlier? We will find out. Okay? Somebody says no. Okay. Let's go and see the box plot. Thank you very much. So if we construct a box plot of current salary, you can see that because of this outlier here, check where the median is. So what can we say about the box plot? What distribution do you observe in the chart? What distribution do you observe? Somebody says no outlier. What distribution do we see? Skew to the right, okay. Another one says skew to the left, okay. Said skewed to the right, okay. Continue, skewed, okay. I can see most people are saying, one person is saying no more distribution. We shall prove that. Okay, skew to the right. Okay, thank you very much. Okay, so let's look at the box plot. I say that if we start from the maximum value to the median, that is one side. If that upper side, the right side, is the same as the lower side from the median to the minimum value, then the data is normally distributed. If the right side, that is the top part, from the median to the maximum value, is longer than the left side, which is from the median to the minimum value, the data has a right skew or positive skew. If the left side from the median to the minimum value is longer than the right side, then the data is skewed to the left. So this data set we see here is skewed to the right. Okay? And the reason why it's skewed to the right is because of those outliers. They are trying to pull the measure of central tendency towards themselves. Okay? So we see the maximum value, the upper quartile, the lower quartile, the median, and the minimum value. So if we look at our data, we find that the least paid person earns 15,750. I'm assuming now you've collected your data, you're writing around the data. So you go on saying the least paid person earns that, the highest paid person earns 135, then 25%, that is the lower quartile, and 25% of the employee earn less than 24,000. Then 75% earn below 37,000. That is the third quartile. Okay? So let's go ahead. Outliers. Observations that are separated from the rest of the values are called outliers. You need to explore the reason for the unusual observations. Outliers could be of interest, if not an error. So practice often do data analysis with and without outlier and compare the results. This is what I was saying, that we can test and find out. If we calculate our average value, for example, of data set A with outlier, we get a certain value, and then compare it with data set B when the outlier has been removed. what happens to the magnitude of the mean. Sometimes it reduces, other times it increases. If it increases because of the presence of outliers, is that increment significant? Do we need to worry about the increment? So I said you can actually test the differences because now we have two data sets, which we assume to be independent. And we can do a two-sample t-test on the mean values, calculate the standard deviation, test the difference between the two. We can also say that, okay, since this data set was collected from the same employee, it is paired. It is correlated. So we use a paired t-test and find out whether the average difference is significant. And if it is significant, that means we have to pay attention to the outlier. It's going to affect the results of our parameters. If we are going to report to another company that company X on average earns this much, we know that with the outlier in, we are going to report a higher salary compared to when we don't have an outlier in the data set. Okay. If it is a mistake, you go back to your data sheets and correct the outlier. For example, if you were entering data and you've coded your data, you have male is 1, female is 0. Now, instead of entering male 1, you enter 10. Then 10 becomes an outlier. It is different from the rest. So for categorical data, how do we identify the outliers? We do cross-tabulation of two categorical variables. For example, we cross-tabulate gender and job category. And under gender, you will see that there is a third category called 10 that you've created because of the mistake that was done. So once you identify that there is a group which you're not interested in, and it is a mistake, you go back to the data sheets and correct the gender of that particular individual. Okay? Okay, let's look at descriptive. Let's look at numerical summaries for a population distribution. We know that in statistics we have two branches, descriptive statistics and then inferential statistics. The descriptive involves numerical summaries and graphical displays. Inferential confirms what you've observed in the descriptive statistics. Now, under numerical summaries, we have measures of central tendency, measures of spread, shape. We also are interested in outliers. Okay? Then, measures of center. We have examples like the mean, which is the commonest measure of central tendency or the commonest measure of center of the distribution. The mean is computed as the sum of all observations divided by the total number of observations. It is highly affected by outliers or extreme observations. Excuse me, I'm sorry about that. The mean is highly affected by extreme observations. We use the trimmed mean to exclude the extreme observations from the calculated mean. So if we calculate our mean with the outliers, we are going to have an inflated value, which is going to paint a different picture. For example, looking at income, we find that income is skewed either to the extreme high or the extreme low, depending on the number of extremes you have. If you have very many extreme lows, then your average income is going to be skewed to the left, where we have very low values. If you're going to have very many people earning a lot of money, or even if you have 5 people earning in billions, your income is going to be skewed to that value, and you'll end up reporting that the people in your country are doing well, yet actually they are not doing well. So for us to avoid reporting values like that one, which misrepresent the income, we can use the trimmed mean. We trim off the observations which are extreme and then compute a new mean, which is representative of what is happening in the population. So the difference between the mean and median, we can see that we have calculated the mean of current salary and years at school. And also we've computed the median. Okay? Remember, mean and median, both of them measure central tendency. You can see that the current salary, the average is 34,420. The median is 28,800 US dollars. Median is not affected by extreme values, because what you do, you arrange your data set in ascending order and then get that particular value occupying the middle position of the data. That is the median. Now, we see that trimmed mean, if we trim off 80% of the outliers, then we are going to see the mean, the trimmed mean becoming 28,000, almost similar to the median. The same applies to years at school. The average median is 12, the minimum median is 13.47. But if we trim off most of the extreme values, we end up with 12.4 as our median. Okay, so that shows you how the mean is highly affected by the presence of outliers. So here we have more values of current salary, and we are comparing the value of mean and median. So when we compute the mean and we do not remove any extreme values, the mean is far greater than the median. If we remove 5% of the extreme values, the mean is far greater than the median. If we go on increasing how many extreme values we are going to remove and remove 25%, you can see that the mean is changing towards the median. And when we look at the median, it has not changed, the value has not changed. It is still 28,800. Okay? So we see that the mean is highly affected by outliers. And in case you have a variable that is extremely affected by outliers, it would be better for you to use the median. Median, as a measure of central tendency, is very robust to outliers and does not change much with changes in the data set. Let me see in the chart. Any question? What is the formula for calculating trimmed mean? Don't our analysis be affected by trimmed mean? My colleagues are going to help me answer those questions. Okay? But I advise you to put such long questions in the Q&A so that in case they are being answered, then they don't disappear. Okay. So as they answer those questions, they will post the comments in the chat and everybody will be able to see whether the data set is affected by trimming off outliers. The other numerical summary is the measure of spread. Spread is a measure of how far a value is from the center. How far a value is from the central value. That is spread. So we find that if we look at that box plot here, examples of measures of spread include the range, which is the difference between the maximum and the minimum interquartile range, the difference between Q3 and Q1. We look at the standard deviation, the variance. All those are examples of measures of spread. Variance and standard deviation. The variance and standard deviation are based on squared deviations from the center, where the center is the mean. So we can see the values for, if we look at this number line, we can see our observations x1, x2, x3, and then the mean is 3. So we want to calculate how far is 1.5 from 3, or how far is 2 from 3, or 2.5 from 3. And we can also find out whether those values are different. So the standard deviation is the square root of variance. So here we have a data set where we've used trimmed data set. We have the range, interquartile range, variance, and standard deviation. Okay, so when you look at the variance, it's quite big. It's 8.3, but compared to our mean, the variance is really small. So the data set does not vary a lot from the observed average. Okay. So let's look at distribution. From here, we are going to do, if time allows, we will do the practicals. If time doesn't allow, then first thing in the morning, we will do the practicals. So shape of the distribution. We've already been talking about skewness. So here we see that we have these two distributions. One is uniform, one is normal. Normal because it has bell-shaped, and if you draw a line in between, one side is equal to the other. That is normal distribution. Okay? So here we have the uniform distribution, no peak. You can see that there's a bit of a peak here and here and here and then here. Okay? In the uniform distribution, it is almost similar to a discrete distribution because in each interval, the probability of selecting anything in each interval is similar to the discrete random variable. But the data set used to construct the uniform distribution is continuous. Okay, let's look at left skew and right skew. So if we look at the first graph, you can see that the left tail is equal to the right tail. So if they are removed, we will remain with only the middle bit. Okay, so for skewed distribution, for symmetric distribution, the right tail is similar to the left tail. Now, we've already said, if the right tail is longer than the left tail, then that data set is skewed to the right. As you can see, the data set is skewed to the right. Let's see what happens in the next one. Now, if the left tail is longer than the right tail, then that type of skewness is called left skew or negative skew. Okay. In a symmetric distribution, the median is approximately equal to the mean and also approximately equal to the mode. Okay. So we've already seen the left skew. In the right skew, the mean is greater than the median, while in the left skew, the mean is less than the median. So we can now change the goalposts. How about if you have qualitative variables? You don't have numerical values. What do we do? Now, the concepts of central tendency, spread, and skewness have no meaning for qualitative nominal variables because they are names. We are talking about male, female. If we get the average male, it doesn't really make sense. Or the skewness of male doesn't really make sense. For qualitative ordinal variables, it sometimes makes sense to treat the data as quantitative for exploratory data analysis purposes. So you can use the median, spread, and skewness under the qualitative ordinal variable. So how about if the variable is quantitative? It has numerical values. Here we see that we can summarize our variable using the minimum, the maximum observation, the median, the mean, the quartile, range, interquartile range, variance, standard deviation. Then we can also use the box plots, histogram. Then we can also look at skewness and also identify outliers. Okay. So in our employee data set, we've already highlighted the qualitative variables, and those include gender, job category, and minority. So for our qualitative variable, we can summarize our data using a frequency distribution, a pie chart, or a bar chart. Okay, so we are going to look at these ones. So the frequency table consists of categories. You can see here in this little table here, these are the categories: gender, female, male. Then the frequency corresponding to each category, and the relative frequency is this frequency here divided by the total number times 100. And then the relative frequency for all the categories should add up to 1. Okay. So we find that pie charts, they are not a very good way of summarizing data set. When we compare the pie chart and the bar graph, somebody will easily read off the value for the bar chart as compared to pie chart. So in this case, you only use pie chart if there is no any other graph that you can construct. So we can have our frequency distribution again for job category and job category. So if we get the frequency for each category, we have the cleric, the custodian, the manager, and we can get the relative frequency. And for you to get the relative frequency, we get the frequency for each category divided by the total number of observations. That's how we are getting these values here. Then the relative frequency should add up to 1. We can plot our data either using a bar graph or a pie chart. You can see that the title for the graph should fall below the graph, and the same applies to the pie chart. From both the graph, bar graph, and the pie chart, we observe that there were more clerics as compared to the manager and cleric and custodian, sorry. Okay, so that particular company employs more of clerical work than other categories. If we look at variable minority, we can summarize it by the two groups, yes and no, and we find that most of the people in the company were not minority, and compute the relative frequency. So 78.1% of the employees are not minority. Meanwhile, the minority are 22%. How about if you want to explore relationships? Or before I go there, any question? Any question? Can we go ahead? Relative frequency. Okay, so I'm told to repeat relative frequency. Okay, we see that we have categories yes and no. Each category has the corresponding number of observations that fall in yes, and also those for no. So to get these values here, 0.219, we are going to get 104 divided by 474. So that gives us that value. The same applies to no, 370 divided by 474 gives us 0.781 as the proportion of people who are not minority. So if we multiply by 100 to get percentages, there are more people who are not minority, that is 78%, as compared to 22% who are minority. So even the minority, when they go to different employees, they end up being minority. I thought that now there would be more people employed, but maybe the order does not matter. Okay, exploring relationship between two variables. What are we talking about? What if you have a quantitative variable and a qualitative variable? Or you have two quantitative variables, or you have two qualitative variables. How do we summarize those variables? We can bring back our box plot. We can use the box plot, as I mentioned earlier on, to summarize our quantitative variables. And we can use a bar graph for each category to summarize the qualitative variables. So you find that the bars, red, green, blue, represent the different categories. Is there a relationship between current salary and employment category? That question goes to you participants. Is there a relationship between current salary and employment category? And if you say yes, why? If you say no, why? So let's see in the chart. Is there a relationship between current salary and employment category? Okay, so people are saying yes. Yes, because the higher the rank, the more the pay. Okay. Somebody is saying no. Okay. Thank you very much. So we see that there is a relationship between salary and employment category. You can see that for cleric, they earn very little, but they're the highest. Now here we are just looking at frequency. It is the highest number of people in the company. Okay? And the least number of company is custodian. So we are going to go ahead and look at salary, current salary. We were asking a question, is there a relationship between current salary and job category? So this gives us the different categories and their salaries. Okay, so you can see that the manager earns best, but also when we go to look at number of years spent in school by job category, you see that the manager has spent more years in school. Maybe he has gained more experience, maybe he has gained more knowledge, hence being called a manager and warranting the high salary. Okay? So we can actually transform our information in the table into a box plot. So you see that this is the box plot for manager, this is custodian, this is cleric. The cleric earns less compared to the custodian, compared to the manager. The manager earns highly because the dark line is our median. So we are looking at the median. Which one has the highest median? It's the manager. Which one has the least? According to the graphs, we see the one with the least median is the cleric. But the reason why it is like that is the way maybe the values were computed. Or in reality, actually the median for custodian is lower than cleric. Though the mean for custodian is higher than the cleric, if you look in the table. So educational number of years in school and job category, we will see that the manager has spent more years in school compared to a cleric. So compared to the cleric, the manager has spent more number of years in school, and also compared to the custodian. So he has amassed more experience and knowledge. That's why he's earning a better salary compared to the custodian. And also when you go for job interviews, they'll ask you, what is your highest level of education? So if you go with a person holding a PhD, for a job of a manager and you have only 1 degree, and we assume that you have the same experience, then the person with PhD will get a job compared to a person with 1 degree. And also the number of years spent in school determine how much that person earns. So if we put these 2 tables together, current salary and educational level, number of levels in years, can educational level explain the differences in salary? Is there a relationship? Okay, so in the chart, can we explain the differences in salary using education? So let's see in the chart. Okay, so if we look at these tables, are we able to tell the differences? Are we able to explain why the manager is earning more than the cleric using the educational number of years spent in school? Somebody is saying yes. Yes, we can. Your educational history will determine your salary. The higher the years of education, the higher the salary. Okay. Yeah. Apparently, the higher the years of school, the higher the years you've spent in school, the higher the salary. That is true even in universities. You will find that a professor earns higher than a lecturer because of the number of years spent in school as well as the experience. Okay. I won't share what my colleagues have just said because you will all, I'll share that when we end the, the training. Okay. So we can actually present our data in form of a box plot. Now, to give a hint, when you're doing your research, when you're analyzing your data, don't present both a table and a figure of the same data. You can either use a figure to explain whatever you want to explain or a table. You can mix match. For one question, you can use the table. For another question, you use the figure. So don't present like the way I'm doing. This is just because I'm demonstrating. But when you're writing up your manuscript, present all a box plot only or a table only. And remember that when we are presenting a box plot, the titles go beneath. My slide had become a bit small. These titles are supposed to go beneath. So don't do as I do, just do as I say, that the titles go below the figures. Okay? So this box plot show the number of years spent in school per job category and also the number of the current salary per job category. We've already seen that current salary, if you look at manager, is skewed to the right, and also cleric is skewed to the right. The custodian, not very sure. We need to expand the scale in order to be able to see our custodian. When you look at education years at school for manager is skewed to the left. Meanwhile, custodian is skewed to the right. And clerical seems to be normally distributed, but this is the median. So it is skewed to the right. So the median is just at the edge. so it's skewed to the right. Okay. So for us to be able to see a relationship between education and salary, we can use other summary statistics like the scatter plot. So we can also look at current salary by gender. What are we doing? We are summarizing a quantitative variable versus a qualitative variable. How do we summarize a quantitative variable and a qualitative variable? You can see if we choose on gender and salary, the male are earning more than the female. The reason I don't know, maybe the male are also highly educated. Yes, if we look at the box plot for male number of years spent in school, we can see that there are more number of years spent in school for male compared to the female. Is there some level of discrimination against male managers? I'm not very sure. We need to look at, I don't think there is any discrimination per se. Maybe not. Okay, so let's look at cleric by gender. So we've cut out data set for cleric and summarize it by gender. So salary for cleric by gender. We see that the male still cleric are earning more than the female. And the years spent in school by the male cleric is more than the years spent in school by the female cleric. Maybe that explains why the female are earning lower than the male. Okay. So let's look at the distribution pattern for a qualitative variable given by their relative frequencies and frequencies. So if we look at job category and also look at gender, we see that there are more clerics in the company compared to all other categories, and as well as more male in the company compared to the female. Is there an association between job category and gender? So for us to see whether there is an association between job category and gender, we need to do a cross-tabulation. Are males and females equally distributed in the different job categories? That one we also need to construct a cross-tabulation. Here we are just looking at the proportions of each category in the company. But with these separate frequency distributions, we may not be able to tell whether there is an association between job category and gender. But with a cross-tabulation, we are able to tell whether there is an association between job category and gender. Okay. So let's construct our cross tabulations between job category and gender. So when we look at the first box shows us the frequency. And we can see that cleric, there are more female clerics than male clerics. If we look at custodian, there are no female custodian. All of them are male. Manager, there are fewer female managers as compared to the male. And we can compute our relative frequency. So here, relative frequency, for example, for the first cell is 206, which is under female, divided by the total number, the grand total, which is 474. So we are able to calculate the relative frequency for all these cells. And from here, we can see that the highest number of employees are female clerics in this cross-tabulation of relative frequency. So we see that the female cleric represent a higher proportion compared to the rest of categories. Okay? We can also use a bar plot, a bar graph, to plot job category versus gender, female, male. Okay? So we can see that for female, still there are no female managers. That's why you see there is no bar representing that group. And meanwhile, in the male, they are evenly distributed across, they are well distributed across the company. All categories have males representing them. So we can look at the cross-tabulation of female gender versus job category. So we know that the totals are the extreme end. Right end are called marginal totals. They are the totals for each rows. They are the marginal total for job category, and the totals for the columns are the marginal totals for gender. Okay? So we can actually also compute our relative frequencies for this marginal distribution and see which particular category is highly represented in the company compared to the other. So within the table, we are able to know within this cleric how many male are there and how many female are there in the company. And then across the categories, we are also able to tell if you're female and going to that employee, you're likely to become a cleric depending on your educational level, and less likely to become a custodian because there are even no custodian female employees in that company. Okay, so this is what I've already been talking about, that we can compute the relative frequencies inside here and talk about them. So we write around the table. Are jobs distributed equally between male and female? No. It appears like gender determines what job category you're going to have. For example, we have no custodial and there are more female clerics. So in this company, they are likely to employ female clerics as compared to managers, female managers. I don't know for what reason. We need to investigate more. Okay? So you can either represent the same information here using a graph or a table. So in your manuscript, you use one of the two, whichever appeals to your eyes. If you want the table, use the table. If you want the graph, you use the graph, but it is the same information that you are looking at. Okay. So is there an association between job category and gender? That one we've seen that yes, there is likely to be a dependency of gender and job category. We will prove these dependencies when we look at chi-square test or we look at log linear regression later in the week. But using the descriptive statistics, we see that we can use our bar graph to see whether there are associations. You can see that the females, we can't get any female custodial, and also female, we get fewer female as compared to managers, male managers, and there are more of female clerics compared to male clerics. So gender plays a big role in determining what job you're going to have at that company, and that goes hand in hand with your experience and educational level. So how about if you want to look at only quantitative variables? Only quantitative variables. Is there a relationship between number of years at school and current salary? Those are the questions you're setting for yourself. Remember, this is a data set that we downloaded from an archive, and then you just formulate questions. So you can also formulate such questions for your research. Does the current salary depend on beginning salary? Does current salary depend on previous experience? So we can answer those questions. So we can use a scatter plot. A scatter plot consists of a variable on the x-axis, normally called the explanatory or independent variable, and then a variable on the y-axis called the response or dependent variable. So in most cases, when an experiment has been performed, when you change the value of the independent variable, then the outcome you're measuring is likely to change. So normally our explanatory variables are those variables which do not change a lot, that you can determine, that you can measure with minimal error. And the response are those ones which vary with any slight change of another variable. Is there a relationship between educational level and current salary? Let me see in the chart. Do you observe any relationship in this graph? And if yes, what type of relationship do you observe in the chart? Or somebody is saying it is lunch. Okay, let's see. Do you need a break as you answer the question? They say yes, positive relationship. Okay, somebody says he doesn't know how to interpret. The higher the educational level, the higher the salary. Somebody says a break is needed. Let's continue. Okay. Okay, thank you very much. So, for you to observe a positive relationship, values either they increase right from this where my hand is. You see that cursor, this particular one? They increase from this bottom going to the left-hand side. Then you know that is a positive relationship. So we see that there is a positive relationship between current salary and years in education. Okay? So we can also find out the magnitude. So if these lines were starting from this point here, the where the y and x meet in that corner there and go out spreading, then we would have a perfect relationship. But you see they are deviating from that line, meaning that the correlation between current salary and years in school is moderate, is not very strong. So we'll look at the magnitude and confirm. Is there a relationship between educational and current salary? We see that there are some outliers which are affecting our graph, and we circled them in red. Those which are very low and those which are very high. Remember that a value is an outlier If it's an outlier, confirm that it is an outlier before you delete it from the dataset, and also confirm that it is likely to affect your results before you decide to delete it. So we've identified some of these values. You can see that number of employee with 8 years of experience are 53, and those with 12 are 190. This is just a summary of years at school and number of employees. And then those ones with 21 years, 20 years, we have one person with 21 years, and then 2 people with 20 years. So those are the ones representing this circle here as outliers. And the 53 are the ones here in this circle here. Okay? Then those with 19 years are 27 of them, also affecting our results. But we cannot remove them until we confirm that actually they can be detrimental to our results. Is there a relationship between beginning salary and current salary? Let me see in the chart. What type of relationship do you observe in the scatter diagram? What type of relationship do you observe in the scatter diagram? Somebody says positive. Yes, positive. Positive what? Linear and linear. What positive relation do you observe? Okay. Linear relationship. Okay. Somebody has said skew to the left. Seriously? Can you see skewness in the scatter diagram? We can only see the relationship and also identify that there are values which are likely to be outliers. For example, if we see in our scatter diagram, there's this particular value here, which is likely to be an outlier, and we can find out whether it is. But there is a positive strong linear relationship between the current salary and beginning salary. Okay, so we can actually draw very many scatter diagrams at a go between the quantitative variables. So you can see this column here is for current salary, the first one. The second one is for beginning. The third one is years in school. The fourth is time on job. The fifth is experience. So we see current salary and beginning salary is the topmost. If the first graph you see here on the second column, and also below the box for current salary, those ones are the same. Current salary and beginning salary has a strong positive linear relationship between those two variables. And then if we look at current salary and years in school, you can see years in school is right here. There is a relationship, but it's not as strong as above. Okay. Then when we look at time on job, there is a very weak relationship between current salary and time on job. The same applies to beginning salary and time of job. You can see it's a random scatter of points, indicating a weak relationship between those two variables. Okay. Then we have previous experience and current salary. We can see that there is a relationship, a linear relationship, but this time instead of being positive, it's negative. You can see the values are flowing downwards. Okay? Most of the values are flowing downwards. So there is a relationship, a linear relationship, but it is negative. Okay? So you can actually draw all your plots at a go and present them in your work instead of drawing like 10 graphs or 8 graphs. you can present them in one go. So here you can also look at the different graphs and look at whether they have outliers. Okay. So this is a plot for male. If we separate our data into female, male, and then draw the scatter diagrams. So like my colleague Helen taught you how to split the data set. You can split your data set by gender and then analyze female alone and also analyze male alone. So you can see a strong relationship between current salary and beginning salary, but a weak relationship between previous years in experience and current and beginning salary. Okay, so this is more of those variables, those scatter diagrams again. And so let's look at correlations. We were talking about correlations in words. Correlations measure the strength and magnitude of a linear relationship. Correlations show us whether we have negative relationship or positive relationship. So the values you see in red are the correlation values for two variables. For example, current salary and beginning salary has a correlation of 0.88. We saw that in the diagrams, we could observe that they had a strong positive linear relationship, and the correlation value is confirming that it is true. Current salary and beginning salary have a strong positive linear relationship. Then we have a relationship between years in school, the third graph, and current salary. So this figure here shows that the correlation value is 0.661, indicating a strong relationship, not very strong and not weak, between years in school and current salary. Then when we look at time on job and current salary, it is a weak relationship. The correlation value is 0.084. Then when we look at previous experience and current salary, it's negative. You see this minus, negative 0.13. It is weak and negative relationship. So in your summary statistics, in your write-up, you can have your values superimposed onto your graph and shown in your analysis. Okay? Okay. So here we present our correlation matrix as another way of summarizing data. So these are the variables we've been looking at as well. So we have our combined data where we have beginning salary and current salary, educational level and current salary, time on job and current salary and previous experience, which you've just seen in the graphs. Then we have a data for current salary, but we've split it into manager, cleric, custodian. So we have manager, cleric, custodian. Then we have female manager, male manager. So those things you can do if you're really interested in going in depth understanding of your data set. So if you look at manager, we find that there is a strong positive correlation between current salary and beginning salary for manager. The same applies to cleric. And also custodial is positive but weak because it is 0.07. So there's a weak positive relationship between current salary and beginning salary for custodian. Okay, so you can go ahead and look at all those in your free time and study the data set so that we see other relationships that we can have. So in the chat, do you need a break before we go into practicals? Dr. Thomas, you have a message here. I would have to go offline. My battery is low, no electricity. Sorry about that. We are really touched. I don't have anything. I can't help you. I'm over here in Uganda. How do we know the relationship is strong and weak? If we have a correlation of over 0.5, irrespective of minus or positive, then that is strong. So if a correlation is below 0.5, then that is weak. If it is equal to 0.5, it is moderate. It says, let's resume at 11 a.m. on Nigerian time. Oh my goodness. Okay, we shall resume at 1 Ugandan time, which is 11 Nigerian time. Lunchtime for Ethiopia. Okay, no problem. Let's have a break. And then we are going to do practical. So when you come back, make sure you download the script, which is called EDA. It's what we are going to use. For now, let's have a break. How long is the break? Up to 45 minutes. Sorry, 15 minutes. Don't go for 45, 15 minutes. 15 minutes break and come back and we do the practicals. Hopefully we can finish them in 1 hour. And tomorrow, my colleague, Dr. Thomas is coming in with very interesting information. Don't miss, because you're going to get more information. So thank you. Let's see each other after a break. Okay. Thank you very much. Are we back from the break? Can I see in the chat whether we are back from the break? Are we back from the break? Okay, thank you very much. We are going to do the practicals of what we've been talking about in the remaining 1 hour. And you're now familiar with R. Open the script called EDA, that is Exploratory Data Analysis. And the first thing we do is to install packages, but I know you've already installed these packages. So go through these packages and see which one you don't have, and put the cursor. For example, if you don't have tidyverse, just put the cursor in the line where there is install.packages tidyverse and run. Don't rerun what you already have. Because I already have all these ones, I'm not going to install those packages, but I'll give 5 minutes for you to be at the same pace with me and make sure you've installed all these packages. Okay? So install packages tidyverse, install R runner, install read Excel, that is read Excel. Then read R, dplyr, plotrix, epdisplay. Okay. I believe my colleague has already told you the use of most of these. ggplot. So make sure you've installed. After installing, go down where they see load and load the packages. So this one I'm also going to do. So I'm loading these packages. So what I do, I highlight. Okay. I highlight and click run. Then in the background, they are loading. Okay. So in case you've not installed any package, don't load it. First of all, first install it. If you see there's anything that you've not installed, just get the name and write install.packages in bracket inverted commas. You write the name of that package. So in the second part here where I've put load, you can see I've tried to explain what each of this package does. Tidyverse for data manipulation. Learner R exports data from R to Excel. Dplyr helps to compute summary statistics. So the meanings are there. Read Excel, plotting 3D graphs, data visualization, that is ggplot2, then ggpur used to create graphs. Okay, so you can see that I have added ggpubr. In case you find it's not part of those which I have highlighted as install, just copy the name and go up and install it. So I'm going to write install.packages. Once you start writing, it highlights, and then I'm clicking that. I need inverted commas. There we go. So in case you find that you've run a package and say doesn't exist, go up where your install commands are. Then you put in install.packages in bracket, inverted commas, ggpur. So this line wasn't there. You can add it. I have highlighted it in blue. Is it visible? Can I see in the chat? Are we together? Please share the script. The script is in the Google Drive. If you go to the Google Drive, my colleagues are going to send out the Google Drive. Having issues, what issues? Please highlight the issues in the Q&A. Charles says, I wait. Yes, we are together, okay. So make sure that you first of all install the packages, then load the packages, and in the process of loading, if anything says that it's not available, that means you've not installed it, and you go and install it. Mary, put the issues in Q&A. Write in Q&A, the issues will be sorted out by my colleagues. Okay? Or you've posted it here. Okay, you've not installed all these packages. You see, no package learner R, no package tidyverse. So make sure you run the first part of the script which says install. Error in library deployer, because it requires some package before it loads. No package, read Excel, no package, all these, the error is actually minimal. Just have to run the first part. Mary, you see this first part here of the script where I've said install packages. Okay? Install packages, highlight. You can highlight all of them like that, like what I'm doing now. And then click the run button. Okay? Setting working directorate, you can use the quickest command. Go to view, session, set working directorate, and then choose directorate. So those who would like to set the working directory, go to session, set working directorate, choose working directorate. That's where I am. And then click choose directorate. So when you choose directorate, then go browse where you've kept your data set, employee. So like me, mine is in day 2. So I click day 2 and click open. So by doing that, you'll see in the console, the command set working directorate is already highlighted. Okay. Okay. So can we go ahead? So after you've installed the packages, you've set the working directorate, go to load. Load the packages again. So for those who have loaded the packages, make sure you've set your working directorate, and you set your working directorate. You can use session window, session at the menu bar, click set working directorate, and then you click choose working directorate. You choose and browse in your documents where your folder is, and then you click on that folder. Mine is called day 2, and click open. So it sets your working directorate. So are we together in the chat? Can I continue? Repeat setting working directorate. My run button is not working. Okay, yes. So I'm going to continue. If you have a query, put it in the Q&A. My colleagues are there. They are ready to help you. Okay. So we've set our working directorate. You can actually run the command. So in this case, don't run what you see. What you see in the script is my directorate. Don't run that, but you can copy what you see in the console and paste it here and run. So what I have left in the script is my information. I was trying to do both. So in this case, I have actually copied the command line in the console for set working directorate. And if you run, you'll have the same thing. So after that, let's go to read, excuse me, read CSV file. So in case it is Excel, you use a different command line. But now we are reading employee, which is a CSV file. So just put your cursor on line 33 and click run. Once you click run, you will see that in the environment window, it is saying that employee has 474 observations and 10 variables. To see your data set, you can either say head, which will print the first 6 values. So if you click run at line 34, you will see the first 6 values of your data set. So in the chat, has everybody read in their data? Please repeat. I just come back and I'm lost. Okay. So what I'm saying is that in the script that you already have called EDAR, put your cursor on line 33. I am assuming you've set your working directorate to where the employee is. So put your cursor on line 33 and click run. Once you click run, you use head to print the first 6 observations. There you go. So I am assuming that everybody is fine. You can use other commands to view your data set. Head is one of them. str describes the structure of your data. So if we run str, it's going to tell you what is in the data. So if I can make this become a bit bigger, you can see that in my console, it says data frame, 474 observations and 10 variables. We have ID, gender is character and consists of M and F. Birthday is a character. Education is an interval. Job category is a character. Salary is an interval. So we can change all those characters to factors because we need to use them in the analysis. So let's see what is going to happen. Okay, so we can also use head 3 employees. If we want to see only 3 observations, you can specify. If you put class employee, it's going to tell you the nature of the data set normally used when you've converted your characters into factors and you want to confirm whether they've changed to factors. You can use class employee. Number of rows displays the number of rows in the data set. Number of columns displays the number of columns in the data set. And then column names to tell you the column names in that data set. So this, I think my colleague really did a good job in telling you what R does, the language. So let's go to descriptive statistics. Today we saw that our exploratory statistics consist of numerical and non-numerical ways of summarizing data. And under the numerical, we have central tendency, which is mean, median, mode. Then under spread over a bit, we have range, interquartile range, variance. Then we can also summarize our data using frequency tables. And under the graphical methods, we shall see, we have box plot, we have the histogram, the pie chart, and the bar graph. Okay, so we can produce summary statistics using the code summary or the command summary, and employee is the name of the data set. So if we all go to line 68, if you've not changed the script, line 68 says summary employee, and that gives us the summary statistics of employee. So let's look at the console. In the console, we have Okay, I'm sorry. I can go back. Okay, if you go to line 68, the code has summary, and that shows that you want summary statistics for the whole of your data set employee. So if you go to line 68 and run that line, you will see values appearing in the console for each variable. So if we click maximize the console, you will see that for all the variables you have in your data set, you have a summary. For example, they are telling us we have gender, birthday. Let's go to job time. So LS beginning salary has been summarized. If you go to the console, you saw the minimum beginning salary is 9,000. The median is 15,000. The minimum is 17. And the maximum beginning salary is 79,780. Then you have summary for job time, where the minimum job time is 63 hours and the maximum is 98. Or job time is in month, 63 months and the maximum is 98 months. Then we look at previous experience in years. The minimum is 0 and the maximum is 476. That is more than a year. So that is general summary. So you can click on this button here to normalize the windows. So we want to get summary statistics for at least one variable, and it is neat and well presented, so it is understandable. So for us to summarize a continuous variable, we can use measures of central tendency, measures of dispersion, or a frequency distribution table. So current salary is a continuous variable, and we want to know the minimum value, the maximum, the mean, the range, the variance, and standard deviation. So if you look at line 71, it consists of the code for writing the summary statistics for salary. And for you to get the minimum, you write mean, MIN, into employee, and the $ is calling the variable salary, which you want to summarize. So let's run that line and also run the next one. So we've run two lines, one with minimum, maximum, mean, another on the range, variance, median. So let's look at the values we've gotten. So you can see in the console, the minimum salary, current salary, is 15,750, and it's giving us the standard deviation SD, which is 17,775. Then on this next row, we have the range, we have the variance, and the median value. Okay? So let's go ahead and see what else we can do with our data set. So how about if you have a categorical variable like gender? If you have a categorical variable, we cannot get the minimum, the maximum of gender. So in that case, we want to construct a table for gender. So you put your cursor on line 75. Line 75 and run. So what we are going to get is just the frequency. And when I look at my console, I've made it a bit. So in the console, I have F and M, where F is female, M is male, and they've given me the frequency, 216 and 258. That is the number of employee, number of female, number of male in the company. So in the chat before we go, should I continue? Any problems so far? Kindly set working directorate and then copy paste the CVS file. Okay, that comment maybe is not meant for me. Please continue. So far so good. Should I continue? Says yes, yes. Okay. Okay. Somebody got lost. You need to tell us where you got lost from. I hope you're not on the streets of Kampala. Yeah? Okay. Okay, so let's continue. And if you're lost, the YouTube is available. You can actually play everything right from the beginning where Helen started. So we've ended at summarizing gender. And what we got was just the frequency of gender, female, male. So how about we have job category, which is also categorical. And we want to run the frequency. So we name the results of the table job, and then we say job is equal to table, employee called job category. So that is line 78. Click run, and you can print job. And it also just gives us the frequencies. We want the proportions. We want the proportions. We want the proportions. So what we are going to use is to use prop.table in bracket job. Gives us the proportions for each category. So if you run line 80, you will see the proportions for each category. But we can't present proportions, so what we are going to do is convert them to percentages. And we are going to round off to 2 decimal places because there are so many. So the next line, line 81, it says round in bracket prop.table in bracket job, close bracket times 100, comma 2 decimal places. So run line 81. If you run it, you see that you have a percentage for cleric, percentage for custodian, and percentage for manager. So in that particular company, we have 76.58 cleric, and there are fewer custodian to the tune of 5.7%. Okay, so that was summary statistics, numerical summaries. So let's see what the graphs say. Okay. So remember, we can construct a bar chart, we can construct a histogram, we can construct a pie chart. So we will start with categorical variables, and we'll start with gender. We want to construct a bar graph for gender, and the command is bar plot table into employee, call gender, then you close the bracket. So we are going to run line 89. And if you look in the extreme bottom corner, you will see a graph. And the graph is a small one. So maybe, is it visible? Is the graph in the plots window visible? Let me see in the chat. Is it visible? You're saying yes. Okay. Thank you. So the graph is visible, and you can see that there are more male than female. But remember, you've plotted numbers, not percentages. Okay? You have plotted numbers, not percentages. Okay? Then dv.off makes sure that our graph has been deleted. So let's continue. So remember that when we do our box plot, our plots were looking up. That is when you are using job category. So probably if you want to make them go horizontal, you use the same command, but add on comma horizontal equals true, then it will flip them. So if you run line 96, so that's how your table, your graph is going to look like. Now, what if you don't want them all to be gray? You want to give them color? You can actually use the color command and make them color. Okay? So here we want also to construct a pie chart, and the command is pie in bracket table in bracket employee call job cut, and then you use different colors. So I'm going to run line 91, and line 91 gives me this small thing here which I'm going to zoom in. So let me stop sharing and share. So this is what we've gotten. It has cleric showing the largest part, manager and custodian showing the smallest part. Okay. Okay, so let's share the R screen. Unless if somebody has a question. Huh? Pardon? Hmm? Oh, okay. Okay, why do we use white, gray 90? These are the colors in R in the palette, which have already been named. So you can go in the palette and choose any other color. You can actually use blue, red, green. Okay? So if we change, we can say white. Let's put here red, and then put here blue, and run. So hopefully you're following. So we run that, and you can see that our pie chart has changed blue, red, and white. Okay? So all these colors are in the palette within R. You can specify whatever you want, but you know that when you're doing manuscripts, you need to put colors which are not colored, unless if you're going to pay for colored graphs. Okay? So we can go on and construct a table with percentages. We've already seen that. So the next, getting percentages for job category and gender. So we've said call is the object. We want to get tabulate gender, job cut. So if you run that and then run the object, gives you the frequencies. Prop.table is giving you proportions. And then when you multiply by 100, you're getting percentages. When you round off, you're reducing. And then you can now construct a bar graph with percentages. So you can see that now our bar graph, instead of having 250 as a maximum value, it has 70. Okay. So we can now plot a scatter plot for salary and then histogram. Because now salary is continuous, we can now construct a histogram. We cannot draw a histogram for gender because the aim of a histogram is to show distribution. But if you already have a categorical variable, you're going to have two bars and you can't even tell the distribution of the data set. So that's why you see we've not constructed a histogram for categorical variable. So as I said, the type of variable also helps you to determine what type of summary statistics or exploratory data analysis you're going to use. Okay. So if we do plot salary, we are just plotting one variable. You can see what comes out is not really very good. It's just a plot of random scatter of points, no pattern, because we have only salary in it. When we use hist, we are telling R to draw a histogram of salary, and if you click on line 120, you get a histogram. So let me zoom into this histogram. So when you look at this histogram, what do you see? What distribution do you see in the chart? What distribution do we see in the chart? Can you tell us? What distribution do you see in the chart? Skew to the right. What distribution do we see in the chart? Somebody says normal. Skew to the left, skew to the left. Okay, thank you very much. Okay, so when we look at this graph here, if the longer tail is on the right hand side, then the graph is skewed to the right. This side you see is the right, and this side you see is the left. So you can see our longer tail is going to the right side. So this is a right skew or positive skew. And in case we get another data showing left skew, the very few values are going to be on the left side, and we call it a left skew. But this one is skewed to the right. Okay, so I'm going to stop sharing. Okay, so back to the script. We've done a histogram and we've seen that salary is skewed to the right. So that tells us that we cannot use the median as a measure of the mean as a measure of central tendency, because those outliers are going to affect the value of the mean. The recommended measure of central tendency is the median, which is not affected by outliers. So we can plot salary, and this time we are saying type is equal to 0 and the column is equal to, let's see what line 123, what it shows us. So you can see instead of having black, we've specified that all those points should become blue. You can add font size, you can increase the font size, you can add that title. So if in the next line shows you how to add the title, you can see salary has popped up once you run the title. I said title in bracket main equals salary, column dot main equals red, And I'm just telling R that my main should be red. And the font of main is 4. Okay. Any question in the chat? Let me see in the chat. Any questions so far? Any questions so far? Okay, so let's go to the next part. Let me see how many minutes we are left with. We still have at least 20 minutes. Let's do the next. Okay, thank you. Attendance for registration. Okay, I've been informed that because you're very few, just 216, you've already been registered on Zoom. So you don't need attendance. Okay. So let's look at relationships between two variables, either qualitative or quantitative. So we can use a box plot to show relationship between variables, or we can draw a box plot for one variable which is continuous. So in this line here, line 133, we are saying draw a box plot of salary, and salary is a function of job category. The data set is called employee. The main title is salary by job category. Name x-axis as job category and y-axis as salary. Okay, so let's run that and see. So those are the box plots you've obtained. Let's zoom in them. Okay. Are the box plots now visible? Can you see them? Okay. So you can see that what we observed in the notes is what we see here. We see that cleric are skewed to the right. The values from the black line here in the middle of every box is the median. So from the median climbing up is the right side, and below the median is the left side. So you can see the right side is longer than the right side, meaning the data of cleric is skewed to the right. Custodian is not obvious to see. Then manager is also skewed to the right because the observations, we observe that the tail on the right is longer than the tail on the left. Okay, so we stop sharing that and share the script. So that is using the command box. How about if we want to use ggplot to construct a scatter and also a box plot? For you to use ggplot, you write gg in brackets the name of the data set plus the geo underscore point indicating that you want to make it a beautiful graph, and x is called salary beginning, y is just salary. So let's run 140 and we see a beautiful graph coming up, which is a relationship between salary and salary beginning. You can see it is a strong positive linear relationship. Okay. So you can also use ggplot, but instead of adding the geo right here, you add it at the extreme end. This is what the second line is saying. So if you run the second line, it gives the same thing. Okay. So you can use the ggplot instead of the plot command. And the last bit of this, hopefully it is the last. We want to convert job category and gender into factors so that we can use it in our descriptive statistics using numerical summaries. So remember I said STR is to check the structure of the data set. So if we put it in, it will show us that gender is a character, and birthday is a character, job cut is a character, job educational number of levels is not a character, is an interval. So we want to change them to a character. Okay, so job category for us, I remember my colleague telling you that you use as dot factor, which is okay. Here I've used factor, job cut is equal to factor, which is also fine. So we can run line 146, and you can see that if you also run the class, it's going to tell us that job cut has been converted to a factor as well as gender. So let's run descriptive statistics by groups. Now we couldn't do descriptive statistics by groups if we hadn't converted job category and gender to a character. So if we want to run summary statistics by group, then we write employee, we put this pipe where it is like a conduit in which you're passing your commands. You don't want to write one by the one, you want to write all of them at a go. So employee pipe, the pipe command, group by job category, again the pipe, display, semicolon, summarize, and then you want the count, you want mean for salary, number of missing equals true, standard deviation for the salary, then number of missing values. Okay, so let's run line 152 and see what it gives us. So you can see that in this case, we are going to have our job category with the minimum salary. So you have the cleric and their corresponding salary and standard deviation and count, custodian, corresponding salary and standard deviation, manager, their corresponding salary and standard deviation. Okay, so let's go back to the script. And I'm assuming there are no questions, so let me see in the chat. But can you also ask the question in Q&A for the panelists? Yes, please put the questions in the Q&A. They stay longer and they can be answered. Okay. Okay, so should I continue? Let me see how many minutes I have. Only a few, 14 minutes left. Okay, thank you. I'm going to continue. And as soon as it reaches 5 minutes to 2, I'll stop. Okay. So we want to construct a box plot of salary as a function of job cut. We've already done that. But let's see what this box plot gives us. We run line 159, and it's the same box plot we've seen so far. But we can also use a ggplot to construct a box plot. If you run line 162, the box plot now is more, has grids, has all those beautiful things in it. So it's more clearer. I hope you can see the box plot in your plot window. And now if you want to construct a box plot, but then you also want the box plots to have different colors, you can go into the palette and open up whatever color you want. So it is the next command, box plot, using the function, the palette function. So we run that line 165, and this time we get box plot with different colors. Okay? Now, if you don't know what palette is, you can put question mark palette, then it's going to give you information about the palette. But you can see it has given us different colors. So in your research, if you are allowed, you can have the different colors for the palette for the different groups. So if I run question mark, I'm asking myself what is a palette, and it is going to tell me in the plot section again, it's going to give you information about the palette, the colors that are in a palette. Okay, then graphs off is going to clear the graphics window. So if we run off, we will see that under our plots, we don't see anything. Okay. Then we want to construct a scatter plot for beginning salary and employee, and add a regression line. You can see add regression dot line, add confidence interval is equal to true. You also add coefficient, correlation coefficient. So all those is specified in this line 175. And when we run, we get a scatter plot. Let me zoom in and share. So you can see that we have, it has printed R, you requested for correlation coefficient, you requested for a p-value, it has printed a line on your data set if you really need it. If you don't need to put the line there. So that's what we've done there. The p-value is small, you can see. It is 0.0, okay, 2.2 to the power minus 16, which is really small, showing us a strong linear relationship between current salary and beginning salary. Okay, so I'm going to stop sharing this, and I'll share the screen. Okay. So here there's a bit of interpreting of values, results. We say the p-value of the test is 2. By the way, the test was testing that null hypothesis, no linear relationship between current salary and beginning salary. Alternative, there is a linear relationship between current salary and beginning salary. So we got a p-value of 2.2 to the power minus 16, which is smaller than 0.05, the significance level, and we conclude that there is sufficient statistical evidence, reject the null hypothesis, and conclude a relationship between current salary and beginning salary. The R value is the correlation coefficient. Okay. So I had my colleague teaching you that you can drop columns from the data set. Now I want to only construct, I want to have only continuous variables so that I can run correlations for many variables and also draw multiple graphs. So what I'm going to do, I'm going to divide the categorical variables, put them in one section, and also have the continuous variables in another section. So this is the last part. So the object where we are going to store our continuous data is called employee1 is equal to the subset, and the data is employee, the original data. Select gender, job category, and what else? Birthday, identity, minority, all things that I don't need. Then you close them up, and let's see what happens next. And then you head. So you've subset, you've removed gender, job cut, and birthday from the data set, employee, and the new data set is called employee1. So let's run line 198 and head. So if you view your data set, we are going to see that we only have educational, salary, current salary, beginning salary, job time, and previous experience only. So that is the data I want to deal with. If you just run the command, it's not going to run. So here we call our object res, and we want correlations for employee. So we run one line 201, and it gives us the correlation for employee. You can see there are many. Because they have so many decimals, we are going to reduce them to 2. So we run, and it gives us the correlation values with 2 decimal places for each variable. So current salary and beginning salary, you can see the correlation value 0.88 as we had seen before. Current salary and education is 0.66. Current salary and job time 0.08. Current salary and previous experience is negative 0.1. Okay? So those are the correlation values if you want to get them from your data set. Remember, if you have some categorical variables, you need to remove them first. So for you to have a correlation matrix with the p-values, you run the function R correlation, and it is found in the HMISC package, HMISC package. Okay? So I can see we only have 5 minutes, and I have my homework, so I'm going to stop sharing and share the homework. So let me share the homework. In the 5 minutes, you can okay, so tomorrow when we come, this is the homework. You've done exercise 1, exercise 2 is using the employee data set and graphical procedure. Display the relationship between 2 quantitative variables, 2 qualitative variables, a qualitative variable, and a quantitative variable. So it is only one question. You can choose the variables of your preference. So that is the exercise we are going to do for tomorrow morning. So please copy it. Let me try to put it also in the chat. Let me go in the chat and put it in the chat. Before they switch off. Exercise 2. Open. So it's there in the chat. It says disk error. Oh, it is open. I can't open it and also put it in the chat as well. So please just copy what you see. Try to copy. And I thank you for being patient with you. We've cruised through the work. Hopefully you've picked something. And tomorrow, let's see the presentation of those 3 questions, and then we will summarize. Thank you for being excellent participants. My colleagues have said that you didn't ask so many questions. That means that you're understanding everything. And we believe that this training is just a recap of what we've been doing, and those who have been on the previous sessions are just revising. And if not, then you're very, very excellent. You're good. Thank you very much. Okay, so I see you tomorrow. Don't miss Dr. Thomas Odong is coming in with new ideas, and they are important for all of you. Thank you. They refused me to share what they were talking. I wanted to tell you, but they've refused. But tomorrow morning, I'll make sure I'm the first on the panel and share with you. Kwaheri. Thank you. Kwaheri. The YouTube is available, by the way. Even now, you can go there and watch slowly and understand. If you didn't pick so much from the training, use the YouTube. Okay. The links have been sent for both day 1 and day 2. So please practice and practice. Practice and practice. Thank you so much. You've been excellent. The materials are in the Google Drive. And even for tomorrow, by the time we start the sessions, Dr. Thomas would have updated the Google Drive. Thank you so much. And Thomas has sent the Google Drive. Thank you, Thomas. And where is the attendance? It has been captured on the Zoom because we are very few. You don't need to register every day. Once you attend, you will be able to be registered automatically. Okay? Thank you. Thank you. Hey, I can't read this, but maybe tomorrow, Justina, you can tell me what it means. Okay. Okay, can you allow me to stop here? I'm gonna mute myself, and I wish you a good evening. See you tomorrow.